Okay, here's a video on Lewis structures. So we have a few ways of doing this. The first one we're going to talk about, just, I guess it's the shortcut version. It doesn't always work well, but you can try it most of the time. You can usually start with something like the example we used in class, PCl3. Phosphorus has 5 valence electrons. Chlorine has 7. And you just fill up each element with its valence shell electrons. And then you notice that we can make a bond here, here, and we're done. So real quick, you use the valence electrons, and then trial and error. So that works most of the time, but not all the time. So another way of doing it, which is the more specific way that has better outcomes, we have different steps. One, we want to sum the valence shell electrons first to make sure we know how many we have. Two, we want to have the central atom with single bonds first. Trying to get a full octet. If you can't, maybe try double bonds or triple bonds. That means double. And we want to fill the valence shell electrons outside in. This gives us then, lastly, any extra valence shell electrons we want to add to the central atom. So with this, using this method, using the same element or same compound, PCl3, P has 5 valence shell electrons, chlorine has 7. So if I have 3 of them, that's 5 plus 3 times 7, which is equal to 26 electrons. First, I start with my central atom. I know this is central because it's the less number. There's only 1 phosphorus and 3 chlorine. There's my 1 phosphorus. I try and make single bonds first with all my elements. Then I fill the outside with full octets. At this point, I can count how many electrons I have. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. It means I have 2 more electrons left. Those 2 more go on the central atom like this. So 2 ways of doing it. They both work most of the time. A lot of this stuff is just practice. Practice, 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 practice. That is the most important when it comes to Lewis structures. The more practice, the better. Practice? You talk about practice? Cool. Sometimes you might have more than one. Sometimes you might have more than one structure that fits. This is what we term as resonance. Resonance structures are when you have different Lewis structures that work. So we end up talking about a few different things. Now, we're not going to go into too much detail about this, but the formal charge indicates which is correct. Now, we're not really going to get into calculating the formal charge. I just want you to know that there is a way to find out which one is correct. But what naturally occurs is usually a mix of both. So it's usually a mix between both. So a perfect example is like glucose. Glucose can either be multiple forms, it's about 50% above. Sometimes it's a ring. Sometimes it's a ring, sometimes it's a linear effect, in the linear effect. They go between each other. So, either way. Cool. Next, we have some exceptions. So that when we're talking about the octet rule and Lewis structures and how things look when we draw them, we have exceptions. Now these are annoying. Sorry. Welcome to chemistry. It doesn't always make sense. Odd number of electrons, less than 8 valence shell electrons, and more than 8. So we have 3 different versions of exceptions. Things that have less than 8, or things that have more than 8. And we talked about in class, PO4. So this is what we consider PO4 3 minus. Now, if we, just to back up, this is 3 extra electrons that are negative. So we have negative 3 charge. Phosphorus has 10 valence electrons connected to it in these 5 bonds. Each bond has 2 electrons, so we have 10 valence electrons for phosphorus. That's totally okay if we in that column of nitrogen, phosphorus, and so on. So things like that, you have to be with more practice, be able to recognize that that's okay. We will go over these in the homework, but remember that more practice is going to make a difference. So if you're not really kind of getting it and you're trying to figure out which one's an exception and which one's not, it comes down to just having more and more practice. But you can always go back and follow the rules. If you follow the rules I set up before, then you'll be just fine on the quiz or assessment that we have. And I think that's it. One last thing I want to talk about is bond and bond enthalpy and bond length. This is the energy used to break a bond. They have different values. Values are in a table. I will give you the values. An example would be like if we have a bond enthalpy of 24 kilojoules minus another bond enthalpy of 18 kilojoules, what's the difference? Things like that. So we're here, we need to do a little bit of basic math. Basic plus and minus when it comes to bond enthalpies. We'll talk about that more in class. But I want you to know from this video that it's the energy used to break a bond. Now bond length refers to the length between these 3 bonds, single, double, and triple. Enthalpy-wise, single bond is the weakest. It takes the least amount of energy to break. Double bond is in the middle, and the triple bond is the strongest. So this one takes the most energy to break. While this one takes the least energy. So, and because of that different energy, single bonds are the longest, while double bonds are in the middle and triple bonds are the shortest. So we have different lengths because these bonds are pulling closer together because they have more energy involved. So you can imagine all these sharing electrons, all of this energy is going this way. Cool. I think that's about it for this video. Check the other one as well, and if you have any questions, write them in the comments. Otherwise, we'll talk about this in class. Thanks for watching.